Morning, good morning. So in the last what I discussed, I think I completed the significant figure, all the rules. Today I have to start instrument. Okay. Calipers or calipers? Okay. So I think everybody has done the experiment and they use the vernier calipers. They at least you have seen the vernier calipers. Okay. So like in a normal scale, what we use or what we are using from the childhood, that scale can measure minimum distance is what? 1 millimeter. 1 millimeter or 0.1 centimeter. Then we want to suppose we want to measure up to the more decimal place, more resolution. Then we use the vernier calipers because vernier calipers can measure up to the decimal 2 place of the centimeter. Okay. Then if we want to get more decimal place, then we use the screw gauge. Like that, we have the so many devices we have. Okay. So normal here. Basically, one vernier calipers we construct in a factory. We will learn the two types of vernier calipers. One what we construct in a factory, and one type of vernier calipers they can construct in a problem. In a problem, they can make any vernier calipers, any hypothetical vernier calipers. Okay, but normal vernier calipers, what we were using in a lab, that vernier calipers has the least count of 0.01 centimeter or 0.1 millimeter. That is a normal vernier calipers that we construct. Its least count is what? 0.01 centimeter or 0.1 meter. But in a problem, they can make any hypothetical vernier calipers. So for that, we have to learn something about how we can measure the least count of the vernier calipers. Least count, maybe already you have learned in the error. Least count is what? It is a minimum measurement that an instrument can measure. Minimum measurement that an instrument can measure. Like normal scale, its least count is what? 0.1 centimeter. Means you can get from the normal scale, you can get 2.1, 2.3 up to decimal 1 place of the centimeter. So normal scale can measure decimal 1 place. Vernier calipers least count is what? 0.01 centimeter. And screw gauge least count is what? 0.001 centimeter. Okay, that is a normally what I said, what we construct in a factory, that vernier calipers has the least count 0.01 centimeter. Okay, yes or no? Getting my point or not? So vernier calipers can measure up to the decimal 2 place of the centimeter. Okay. So in a vernier calipers, if you have seen, so we have the 2 scale in a vernier calipers. Okay, least count. Okay. But what I'm writing here, this vernier calipers, I am saying what we use in a lab. But in a numerical problem, this data may change. So we will find the least count according to the data given in a numerical problem. But generally what vernier calipers we use, its least count is what? 0.01 centimeter. So don't mug up it, and in all the problems you are applying 0.01. For the different problem, it will change. So this what I'm writing, that we use in a lab, what we construct in a factory, that vernier calipers we can say its least count is 0.01 centimeter. Otherwise I will say the least count formula that you will use in a different numerical problems. Okay. Now in vernier calipers you have seen there is a 2 scale. One scale that is a fixed, and one scale that you can like there is a one sliding scale is there. That sliding scale is the we call vernier scale, and one scale that is a normal scale what we are using That is a main scale. So Vernier calipers has the two scale. One is the main scale, one is the Vernier scale. Okay. Main scale, normal scale. So normal scale, we know that there are the big divisions. Like suppose this is the 0, 1, 2. In between there will be the 10 small divisions will be there. Okay. So normal scale has a what? It can measure 1 millimeter. Minimum distance it can measure 1 millimeter or 0.1 centimeter. So that scale is called the main scale. Okay. And other one is what? There is no any marking is there. Only divisions are made. In the other scale, there is only divisions. They will make the divisions like this. So equal divisions are there. So that scale is called Vernier scale. So in a Vernier calipers, we will have the two scale. One is the main scale. Main scale is a normal scale. Okay, that has a least count of 1 millimeter. 1 millimeter or 0.1 centimeter. That already we have used in an error. Okay. Second scale is what? Vernier scale. Vernier scale has equal number of divisions. We don't know what is the distance between each division. Like in a normal scale, we know. Like this division is equal to what? 1 millimeter. In a normal scale, we know. Main scale, we know. One division is the 1 millimeter. But Vernier scale, there will be the division only. No any marking is there. We cannot say what is the length of each division. Understood or not? But we can count how many division it has. We can count. Got it or not? So Vernier calipers, two scale. One is the main scale. One is the Vernier scale. Main scale is the normal scale. It has a least count of 1 millimeter or 0.1 centimeter. Which value you are mugging? That value you will mug up with the proper unit also. Because in the exam, suppose you got the confused millimeter or centimeter. Okay, then you will do wrong. So like suppose 0.01. I'm mugging the Vernier calipers least count. So 0.01 centimeter or 0.1 millimeter. That you have to remember. Okay. So Vernier calipers, two scale, main scale and Vernier scale. Okay. Now, first we have to know what is the least count of, what is the minimum distance the Vernier calipers can measure. What is the minimum distance that Vernier calipers can measure? Okay. So for that, we have to learn the least count formula. Okay. Least count of main scale is what? 1 millimeter. That maybe you have learned in the error. Least count error you have learned. So there you have used the main scale. Okay. But I'm writing here least count of main scale is a normal main scale is a 1 millimeter. Because each division of the normal scale, main scale is what? 1 millimeter. This is a normal scale, what we are using from the childhood. Understood or not? Okay. So now what I'm saying, least count, how we will calculate the least count if it is not the actual Vernier calipers, any hypothetical Vernier calipers they are asking. Okay. So least count of the Vernier calipers. So least count is equal to 1 MSD minus 1 VSD. That formula you have to remember for the least count of Vernier calipers. Least count of Vernier calipers is the 1 MSD. 1 MSD means main scale division. 1 main scale division minus 1 Vernier scale division. 1 main scale division minus 1 Vernier scale division. Okay. Understood or not? Like in a main scale, 1 centimeter divided into the 10 equal division. 1 centimeter divided into 10 equal divisions. So each division is equal to 1 by 10 centimeter. 1 by 10 centimeter means 1 millimeter or 0.1 centimeter. In the problem, they will give the data. What is the main scale division? Understood? Okay. Now 1 VSD. That 1 VSD means Vernier scale division. That we cannot say directly. For this, they will give the data. What they will give? So in a problem, they will say like 10 main scale, 10 Vernier scale division, 10 Vernier scale division coincide with 9 main scale division. 10 Vernier scale division coincide with 9 main scale division. Okay. It means 10 Vernier division is equivalent to what? 9 main scale division. If they are giving this type of data, 10 Vernier scale division is equal to 9 main scale division, or 10 Vernier scale division coincide with 9 main scale division, it means we can say 10 Vernier division is equal to the 9 main scale division. Understood? So for that, suppose I am saying X Vernier scale division. They will give the value of X, like 10 division, 20 division. So X Vernier scale division is equal to Y main scale division. So they will either say X division of the Vernier scale coincide with Y division of main scale. It means what? X VSD is equal to Y MSD. Okay. X division of Vernier scale coincide with Y division of main scale. Okay. Then we can write this mathematical relation, X VSD is equal to Y MSD. Okay. Then we can say what? 1 VSD. 1 VSD is equal to what? Y by X MSD. Okay. Now 1 VSD I got. So least count formula, what we have? Least count is equal to 1 MSD minus 1 VSD. 1 VSD we can say Y by X MSD. From that MSD you can take common. So 1 minus Y by X MSD. And we will put the value of MSD whatever they will give in a problem. Okay. Understood? But this is not a formula. We will not mug up, because we will try to mug up the less formula. Because when you will mug up more formula in the exam, you will get confused and important formula you will forget. So that's why we will try to mug up minimum things in the physics. Okay. So this is not a formula. Procedure you have to know. Whatever they are giving, this division is equal to this division. From that you can find the 1 VSD by this way. Understood? Okay. And then we will put the MSD value. MSD whatever they will give, we will put. Then you will get the least count. Got it? So one problem we will do on this formula. In Vernier calipers, if 20 Vernier scale division coincide with 16 main scale division, then find least count of Vernier calipers if in main scale one centimeter is divided into 10 equal division. Okay, so we have to find the least count of the Vernier calipers in which 20 Vernier scale division coincide with 16 main scale division, and in a main scale they have given data for the MSD. What? 1 centimeter is divided into 10 equal division. Okay, so 1 MSD is the 10 equal division. So 1 centimeter they are saying divided into 10 parts. So one part will be what? 1 by 10 centimeter. In a main scale, 1 centimeter divided into the 10 part. So each part will be 1 by 10. 1 by 10 means 0.1. So from this I can say 1 MSD is equal to what? 1 by 10 centimeter, or we can say 0.1 centimeter. From this data we got MSD. Now for the VSD they have given 20 VSD is the 16 MSD. So we can say what? 20 Vernier scale division is equal to 16 main scale division. Then 1 Vernier scale division, what you will get? 16 by 20. 16 by 20 is equal to what? 0.8 main scale division. Okay. Now main scale division we already know, that is a 0.1. So we will replace the MSD by 0.8 into 1 MSD is equal to what? 0.1. Then you will get what? 0.08 centimeter. So 1 Vernier scale division we got 0.08 centimeter. Okay. Now I have MSD, I have VSD. Then I can calculate the least count. What is the least count formula? Least count is equal to 1 MSD. 1 MSD is what? 0.1 minus 1 VSD, that is 0.08. Then what you will get? 0.02 centimeter. .25 how? What you will get? I will give one more first. You got this answer or not? Who is getting 0.25? Okay, okay. Everybody understood? 0.02. Okay. Okay, okay. Now one more problem will do. Okay. Sir, should we use those three formulas? Which three formulas? No any formula is there. Only that you have to remember the procedure, that what they have given. This number of Vernier scale is equal to this number of main scale. From that you have to calculate the VSD. And only one formula you have to remember. Least count is equal to 1 MSD minus 1 VSD. In the problem you have to search where is the MSD, how we can find the VSD. Okay. Now next. In main scale, 1 centimeter divided into n equal division. Okay. And n Vernier scale division coincide with n minus 2 main scale division. Then find LC. Then find least count. Online कब तक चलेगा? Maybe that live, YouTube live, maybe this week only. Vikram, why you have the problem? Okay, so in main scale, 1 centimeter is divided into the n equal parts. Okay, and n Vernier scale division coincide with n minus 2 main scale division. Then we have to find the least count of the Vernier calipers. Okay, 2 by n square. Very good. 2 upon n power 2. Very good. Very good. 2 upon n square. Very good. Now in a one attempt the people understand. Very good. Okay, means most of you got the right answer. Okay, so here 1 centimeter means MSD, we can say what? MSD is equal to 1 centimeter divided into the n part. So each part will be 1 by n centimeter. So we can say MSD is equal to what? 1 by n centimeter. Okay. Now for the VSD they gave the data. N VSD coincide with n minus 2. So we can say what? N VSD is equal to n minus 2 MSD. So 1 VSD what I got? N minus 2 upon n, and MSD is equal to what? 1 MSD is equal to 1 upon n. So that you got n minus 2 by n square centimeter. I know the formula now. I have written 1 minus 1 y by x, but I'm not using that because in the exam you will forget. Why? What was the y? What was the x? You will get confused, so you will do wrong. So that's why we have to follow this procedure. It will not take more time. Okay. Everybody got or not? Now then, least count what we will say? 1 MSD minus 1 VSD. So 1 MSD is equal to what? 1 by n centimeter minus 1 VSD what? N minus 2 by n square centimeter. Now n square you can take LCM. So n square, then n minus n plus 2. So n and n cancel out. So 2 upon n square centimeter. This is the least count of this Vernier calipers. Okay. Okay then. Now maybe if you have, when you have done the vernier, you have used the vernier calipers. So vernier calipers has one manufacturing, maybe it may have the one manufacturing defect. Okay, that is called the zero error. So we have to know what is a zero error. So in the error also you have learned the zero error. Okay, so zero error is the what? It is the instrumental error of the vernier calipers and screw gauge. Zero error is the instrumental error, because this we have to learn only screw gauge and vernier calipers. So zero error is the instrumental error of the vernier calipers and screw gauge. What is the zero error? How you check the zero error? So if before measuring any length from the vernier calipers, first we have to check that our instrument is correct or not. So for that, what you will do, if you have seen the vernier calipers, it has the two jaws. Jaw, the shape like this. In between, if whatever you want to measure, that object you put in between the jaw. Okay, this is the fixed, this is the sliding, other one is the sliding. So if you are not putting anything, so before using it, what you will do, you will check the my instrument is correct or not. So you will join both jaw of the vernier calipers. When you join the both jaw of the vernier calipers, it means you are not measuring any length. Okay, so if the zero of the main scale, one zero on the main scale, so if the zero of the main scale, suppose this is the zero of main scale and zero of the vernier scale, if the joining the jaw, zero of the main scale and zero of the vernier scale, they are coinciding, means they are on the same line, it means our instrument is free from zero error. This instrument does not have zero error. On joining the jaw, if the main scale and vernier scale zero are coinciding, so means this instrument does not have zero error. Understood or not? Okay, so by that way, if it is a coinciding, so we can say it does not have error. Okay, now that is another possibility is what? Main scale zero is fixed, vernier is sliding. Okay, so main scale you will take as a reference. Other condition is what? Maybe the vernier scale zero is the left of main scale zero. Vernier scale zero is the left of main scale zero, and it is also possible that vernier scale zero is the right of main scale zero. So three possibilities are there. Their zeros are coinciding. So when the zeros are coinciding, no zero error. Okay. When zero of the vernier scale is the right of the main scale, right of the right positive you can think. So when zero of the vernier scale is right of the main scale, then it will have the positive zero error. Then instrument will have the vernier calipers will have the positive zero error when zero of the vernier scale is the right of main scale. Got it or not? And then other what? If the zero of the vernier scale is the left of the main scale, then it has the negative zero error. Everybody got or not? Okay, so zero error is what? It is an instrumental error. Already we have learned in the error, instrumental error comes in the category of the systematic error. So suppose they are asking the question, zero error belongs to systematic error, random error, then we can say zero error is the instrumental error, and instrumental error come in the category of the systematic error. Why? Because we can find the reason of the error, we can find the zero error, and we can rectify the zero error also. Okay, so that's why zero error come in the category of the systematic error. You'll remember now. Sir, left means negative. If the who's left? Main scale is the fixed. Vernier we have to move. Vernier zero is the right of the main scale, positive zero error. Vernier scale zero is the left of the main scale, negative zero error. Okay. So I'm just writing that 0.0 error. So if joining the jaw vernier scale 0 and main scale 0 coincide, then no zero error. Okay. If vernier scale 0 is right of main scale 0, then positive, 0 error. Third one is the Vernier scale 0 is left of main scale 0, then negative, 0 error. Okay. So in NCERT they have not given more detail error and all, so that's why up to this only it is a more than sufficient. Okay. Okay, everybody got now? Okay, so now we got the 0 error, and when the error will be positive, when the error will be negative, then we can say, okay. Now 0 error completed. So suppose now I have my instrument has the 0 error or not, it has a positive error or negative error, then we will measure any length. So we will put the object between the jaw of the vernier calipers. Okay. Reading, how you will measure? So reading of the vernier calipers. Okay. So reading means what will happen when you put some object. So like suppose it is a main scale. This is a main scale 0. This is a big division 1, then small division, and then your vernier scale is started from here. And third division may be inside. Suppose after putting some object, your other scale, vernier scale 0 started from, it crosses the main scale 1 big division, then a small 2 small division. Okay. So I can say what is the main scale reading? Main scale reading, the 0 of the vernier scale is between 2 and 3. Between 2 and 3. So I can say the main scale reading is what? 1.2. Main scale reading is what? 1.2, because 1 big division crossed, 2 small division crossed. Everybody is getting or not? But in the problem in the NEET, they will directly give the main scale reading is this. They will give main scale reading is this, directly will take as a main scale reading. But in the figure we can take what? Suppose the vernier 0 started from after the 1.2, it is between 2 and 3. So I can say the main scale reading is the 1.2. But they will give in the problem, they will give the main scale reading. Okay. So vernier reading of the vernier calipers, what we can say? MSR. MSR means main scale reading. Main scale reading they will give. Okay. Everybody got or not? Then next is the VSR. VSR is what? Vernier scale reading. I will say how to find the vernier scale reading. Okay. Somebody know some books also they use a different notation for this. I am using the MSR, and for that vernier scale I am using the VSR, vernier scale reading. From other book, don't get confused. I will say what is the meaning of VSR. Okay. So MSR plus VSR. Now maybe our instrument has a 0 error. Okay. So if they are not talking about the 0 error, means instrument does not have 0 error. Otherwise they will mention positive 0 error this or negative 0 error this. They will give the error with a sign. So maybe somebody mugged up positive error we subtract, negative error we add. But in the exam maybe we can get confused. We have to add the positive error, we have to subtract the 0 error. So we will follow this one rule, only one rule. What? 0 error we will always subtract. 0 error we will always subtract, but with the sign. 0 error we always subtract with the sign. If the positive error, you will put the sign means positive, and if it is a negative error, then you will put the negative. Getting my point or not? So 0 error we will always subtract. 0 error we will always subtract with sign. With sign means positive error, so you will put the value positive. If it is a negative error, then you will put the value with negative sign. Getting my point? So like positive error, subtracting, so minus positive, it means positive error, ultimately the positive error we have to subtract. Positive error we have to subtract. So what I'm saying here, minus 0 error with sign. Okay. So sign means positive error. So here you will put positive. Now positive, but outside what is there? Minus sign. So it means negative error, positive error you are subtracting. Positive error you are subtracting. Yes or no? When it is a negative error, so negative, you will put the zero error with the sign minus. Negative error is the minus. Minus minus will become plus. It means negative error we are adding. So who has mucked up? Who has mucked up? Positive error subtracted, negative error added. From that you can get. So we have to follow one. Zero error we will always subtract, but with the sign. If positive error, we will put the positive. If the negative error, we will put the negative. Negative, negative, then it will become positive. Okay. So MSR, VSR minus zero error with the sign. This is the reading of the Vernier calipers. Okay. Syllabus. This weekend syllabus may be updated syllabus you got. The weekend syllabus is up to the expansion of solid only. Okay. So later in the next week's small portion we will add in every week because syllabus was already lagging. So small portions we will add, and then after few weeks we will balance. Okay. So this week thermal expansion of the solid, up to the thermal expansion of the solid is the syllabus. Whole syllabus, you started now, you're thinking about the whole syllabus. So whole syllabus we will complete in a maybe Jan or Feb we will complete. Okay, now I can start. Because this year that is a possibility, maybe the NEET they will conduct early. So that's why we have to complete the syllabus early also. Okay. Okay now. So MSR, VSR minus zero error with a sign. Now MSR they will directly give. VSR they will not give. So what is the meaning of VSR? Now VSR, how you'll find? VSR is equal to N into least count. Now everybody knows the least count. Least count we know. Now what is the N here? So N they will say the Vernier scale division. So N is the what? Vernier scale division in reading. That coincide with any division of main scale. So what you will observe when you are measuring something, so you got the main scale reading. After that, what you will see, if you see the Vernier scale, so any division of the Vernier scale will definitely, it will be on the same line of main scale. There doesn't matter which main scale division, but any Vernier scale division will coincide with the main scale division. Any Vernier division will coincide with the main scale division. That Vernier scale division you have to count. In the problem they will give that Vernier scale division. Suppose you are saying 6th division of the Vernier scale coincide with any division of the main scale. Then in that case, for the reading N value, what you will take? 6. So to calculating the VSR, VSR means what? N into least count. What is the N there? N is the Vernier division, any Vernier division which is coinciding with any main scale division. So that N value, that Vernier division we will take as a N. Understood or not? And this N is different from that, what they are giving. This N Vernier scale division is the N minus 1 main scale division. That is different. That we use to calculate the least count. That data they will give to calculate the least count. But when you are measuring any length, then they will say Vernier scale division is the 6. Vernier scale division in the 6 in the reading. Then what is the N value here? You will take 6. For that they will not give which main scale division. They will say in a reading Vernier scale division is the 6. Okay, so N value we will take 6 into least count, then you will get the VSR. Got it or not? Okay. So one data they will give for the least count. So like 10 division of the Vernier scale is equivalent to the 9 division of the main scale. That data they have given for the least count. Then for the reading they will give the N value Vernier scale division. That Vernier scale division here you will take the N value. Okay. So one problem we'll do on this. So if 10 Vernier scale division coincide with 9 main scale division and 1 MSD is equal to 1 millimeter. Okay. So in measuring length of object, main scale reading is 2.4 centimeter and 6 Vernier scale division. Then find length. If 0 error is equal to minus 0.02 centimeter. Okay, so if 10 Vernier scale division coincide with 9 main scale division, and main scale division they have given 1 millimeter. So we are measuring any length from the Vernier calipers. In that they have given the main scale reading is the 2.4 centimeter and Vernier scale division is the what? 6th division. Then we have to find the length and 0 error they have given minus 0.02 centimeter. Okay. Then first data they have given for least count. Okay, so what is the least count we can find? So 10 Vernier scale division, that is equal to what? 9 main scale division. Now 1 VSD I can say what? That is equal to 0.9 MSD. MSD is what? 1 millimeter, but all other data they gave in a centimeter, so we will convert into the centimeter. Okay, so 1 millimeter is the 0.1 centimeter. Then you will get 0.09 centimeter. Then least count, what we got? Least count is equal to 1 MSD minus 1 VSD, means 0.1 minus 0.09, that is equal to 0.01 centimeter. So by this data we got the least count of the Vernier calipers, that is a 0.01 centimeter. Okay, up to this any problem? Okay, now then what is the length of the object? We can say length of the object is equal to MSR. MSR they have directly given 2.4 centimeter, so we have put the MSR plus for the VSR what we will take n into least count. What is the n? They have given 6 and least count what we got? 0.01. So MSR plus VSR minus 0 error with the sign. What is the 0 error they have given? Minus 0.02. So minus 0.02. Okay, then what you will get? 2.4 plus 0.06 plus 0.02. Then what we got? 2.48 centimeter. How you are getting 2.36? Suhas, how you are getting 2.36? Got, sir. Okay. Okay. So everybody got it or not? So this is that is the toughest problem for the NEET, that this type of data they can get. Otherwise they will give the least count directly and they will give the main scale reading directly. Most of the cases they don't give the 0 error. They don't give the 0 error, it means instrument does not have 0 error. Okay. Completed. Now next is the screw gauge. MSR will always be given, or otherwise MSR they will give, otherwise some data they will give. So MSR they will give, so we cannot find the MSR. Okay. Completed. Now screw gauge is what? If you want to measure decimal 3 place, up to the decimal 3 place in a centimeter, then we use more precise device, that is a screw gauge. Okay. So normal screw gauge has the least count is what? 0.001 centimeter. Like that way you can remember. Normal scale 0.1 centimeter, Vernier calipers 0.01 centimeter, and the screw gauge 0.001 centimeter. Okay. But again what I said, that is the 2 types of Vernier calipers or screw gauge. One, what we construct in a factory, what we construct in a problem. In a problem we can make any hypothetical screw gauge or Vernier calipers. Okay. So but normally what screw gauge we use, it has a least count of 0.001 centimeter. Okay, so like suppose I'm saying that any data, any length I'm saying, that length has measured by using the screw gauge, that length measured by using screw gauge. Okay, and I'm sending the data, to anyone. So I'm sending, like suppose length is a 1.2 centimeter, 1.22 centimeter, 1.220 centimeter. Then which data is the more, which data is accurate for the screw gauge? Third one. Why? From the significant figure we know that we have to write up to the 3 decimal place, because screw gauge can measure up to the 3 place of the decimal. So among these data, which data shows the correct significant figure or not? So that is the third data. Why? Because it has given up to the decimal 3 place. Understood or not? Not more precise. More precise we cannot say. Precision is the okay. Among these 3 data, third data is the more precise. But on the basis of the instrument, here we have to recognize. Okay, like this first data I can say this came from the, if this data is coming, so I can say this data came from the normal scale. Okay, if I'm sending this data, so I can say this data came from the vernier calipers, and this type of data, it means it is a came from the screw gauge. Okay, so from the screw gauge we will write the decimal 3 places. If we are getting the not third place, so we have to put the 0, then I will say this is the screw gauge. Okay. Now again we have to define the least count and all for the screw gauge. So first, in the screw gauge, if you have seen, that is a small device. Okay, there one circular, one nut screw is there. When you rotate it, so nut or screw moves in a horizontal direction. In the common practical we have seen, when we tight the screw, what happens? The screw goes for in the horizontal direction. So in a screw gauge we have the 2 scale, like a vernier calipers. In a screw gauge, one main scale and one circular scale. In a vernier calipers we have one main scale, one vernier scale. Okay, so in a screw gauge we have the 2 scale, one is the main scale, one is the circular scale. In a vernier scale, division or vertical divisions was there. In a circular scale, that is like a cylinder. Circular scale, horizontal divisions will be there like this. Okay, so like this is the main scale, this is a circular scale. On the circular scale, division will be like this. Okay, and one reference line will be there. From that we can measure 0, which division is coinciding with the reference line. So this is the screw gauge. This scale is the main scale, this is a circular scale. Circular scale has the number of divisions. Okay, getting my point or not? Everybody got up to this? Okay, now in the screw gauge, one screw is there. When you rotate this, then nut or screw moves in a horizontal direction. Okay, so in a one rotation of the screw, when you give the one rotation, complete rotation, in a one rotation of the screw, how much horizontal distance moved by this? Okay, how much horizontal distance moved by the main scale we can say. So that is called the pitch. We define one quantity, that is pitch. So in a one complete rotation of the screw, how much horizontal distance moved by the scale, that is called the pitch. Understood or not? But pitch is defined for one rotation, one complete rotation, how much horizontal distance moved. Okay, pitch is not the least count. Pitch is only the distance that is moved by the scale, main scale, in a one complete rotation of the screw. Okay, now suppose I am saying in a 4 rotation, when we give the 4 rotation, distance moved by the main scale is the 2 millimeter. In a 4 rotation of the screw, distance moved by the main scale is 2 millimeter. What is the pitch? One by 2 millimeter. Why? 4 rotation, 2 millimeter. So one rotation pitch is defined for one rotation. So 4 rotation, 2 millimeter, one rotation, 2 by 4. That is equal to 1 by 2 millimeter. Okay. So then we can say what? Pitch is equal to what? Distance moved by main scale upon number of rotation given. And sometimes they will not give this pitch data. They will not give how much horizontal distance. So which basically pitch will come the least count of main scale. If they have not given, basically the pitch is equal to what? Least count of main scale. So if they have not given the data about the pitch, they have given the main scale division is the 1 millimeter. So you will take that is basically that is a pitch. So least count of the main scale is the pitch. Understood or not? Okay, so main scale least count. Main scale least count is the pitch we can take if they have not given the data for the pitch. Okay. Okay then. So pitch we can calculate by this. Now least count of screw gauge we can say. That is equal to what? Pitch upon total number of division on circular scale. Okay, so we can say the least count of screw gauge is equal to what? Pitch upon total number of division on circular scale. This is the formula of the least count of the screw gauge. Okay, completed. Okay, now pitch least count. Now after getting the least count, how we can get the reading of the screw gauge? So again, like the same Vernier calipers reading, we can say what? Reading is equal to MSR plus, in the place of VSR here circular scale, that's why we will take the CSR, circular scale reading. So MSR plus CSR, and it may also have the zero error. So what I said, zero error we always subtract. So zero error with sign. So MSR plus CSR minus zero error with sign. Okay. Now again MSR they will directly give, zero error they will give with a sign. Now how we will calculate the CSR? So CSR is equal to what? Same like a VSR. CSR is equal to N into least count. What is the N here? N is the circular scale division coincide with reference line. Or directly they will give circular scale division. So that directly circular scale division reading means what? We have to take that value as a N. MSR plus CSR into least count minus zero error also we can write. So what I said, in the different books they have represented the different. Okay, so means CSR, what you are saying na, MSR plus CSR into least count, that CSR means you are taking as a N. But I am writing the CSR is equal to what? N into least count. So whatever the you have learned, you can follow that also. Okay, that's why I am saying different books may use the different. Okay, understood or not? Now here the same, and we will take as a circular scale division coincide with reference line, or directly circular scale division we will take as N. Okay, now in a screw gauge also we may have the zero error, but I think there is no need to go in the detail in the zero error of the screw gauge also. But what is that defect? When you join the screw with the one end of the screw gauge, so reference zero of the main scale, zero of the circular scale should lie on a reference line. If the reference line and the zero of the circular scale coincide, means instrument is free from zero error. Other chances, other possibilities, what? Zero of the circular scale may be above of the reference line or maybe below of the reference lines. On the basis of that, negative zero error and positive zero error. But we should not, there is no need to know, because they never asked about the error and they have not given in detail about the error in the NCERT. Okay, so error they will give, so the error value directly they will give with the sign. We have to put here directly in the reading. Got it? Okay, so we will do one problem on this. So if pitch of screw gauze is 1 millimeter and circular scale has 100 division. Okay, to measure diameter of wire, main scale reading is 0.2 centimeter and circular division is 25. Then find diameter of wire. Okay, if zero error they given, minus I'll give the plus 0.002 centimeter. Okay, now tell what is the answer. Zero point 0.0223. 0.223. Okay. Then reading, what we will say? First we will calculate the least count because directly they have not given the least count. So least count, what we can say? Least count is equal to pitch they have given 1 millimeter, 1 upon total number of division on the circular scale they have given. If pitch directly given, it is okay. Otherwise, they will give the number of rotation and distance moved. Okay, from that we can calculate the pitch. So pitch upon total number of division 100, so means 0.01 millimeter. That we can write as 0.001 centimeter. Okay, so this is the least count we got. Now for the reading, what we will take? So reading means we are measuring the diameter. So diameter we can say MSR. MSR they have given 0.2. Okay, then CSR. CSR we will say what? N into least count. Which division they have given? Circular scale. N value they have given 25. Into least count is what? 0.001. Okay, minus zero error. Zero error directly they have given positive, so you will put here positive. So 0.002. Okay, now 0.2, this you will get 0.2 plus 0.025 minus 0.002. Then after adding, what you will get? 0.223 centimeter. So diameter of the wire is the 0.223 centimeter. Okay. So like 2021, they gave the main scale reading is the 0, circular scale reading is the 30, no zero error they given, and least count data they give, least count 0.001 centimeter. So what is the reading of the screw gauze? So main scale reading they give 0, so 0. 30 division of the circular scale, so 30 into least count. Least count they given 0.001. From that what you will get? MSR 0 plus 30 into 0.001. So 0.003, that is the answer. This type of simple question they will give. Okay. Everybody got or not? Okay now. So now this instrument is over. Now we have to start thermometry. Okay. this. So in a thermometry, we have to deal with the first some is sir, one more question properties. Now the simple same data I will give what is required. What I said NEET also they asked the question 2021 MSR they given 0 and the CSR they given 30 and the least count they given 0.001. What is the reading of the screw gauge? So main scale reading is the 0, circular scale reading is a 30 into 0.001, no zero error, so directly you will get the answer. Okay. Assignment. Okay, I'll try. Okay. Assignment will upload. No problem. Okay. Now thermometry we have to start. So in the thermometry, some basic idea may we have. Maybe you don't have. Somebody has. Somebody don't have. So we know the some scales like Celsius, Fahrenheit, Kelvin. Others are there, Reaumur and the Rankine, but we don't have to talk about them because they have not given in the NCERT. So only we have to deal with the three scales: Celsius, Kelvin, and Fahrenheit. Okay. So, but thermometer, what is a thermometer? At least we know that. What is a thermometer? To measure the temperature. Okay. In a thermometer, we use a property that changes with temperature. Different thermometer, we use the property that property changes with temperature. So this type of property is called the thermometric property. The property that changes with temperature is called thermometric property. Okay. Like if I say at constant volume, just listen first, I will write. So suppose I am talking about the volume of a gas at constant pressure. So we know that at constant pressure, volume of a gas is directly proportional to temperature. If we increase the temperature, then volume of the gas will increase at constant pressure. So we can say the volume of a gas, we can take the volume of a gas as a thermometric property to construct thermometer. Okay. Similarly, at constant volume, pressure is directly proportional to temperature. So I can use the pressure as a thermometric property. Okay. So when we increase the temperature, pressure of the gas will increase when the volume is constant. So pressure of the gas we can take as a thermometric property. Then we know the expansion of liquid. We know when we increase the temperature, liquid expand. So volume of the liquid we can use as a thermometric property that we use in a mercury thermometer. When we put the mercury in a glass tube and when we put in a hot body, hot environment, then what happens? Mercury get expand. When it get expand, according to that, it shows the different reading. Okay, so volume of the liquid we can use as a thermometric property. Resistance of the conductor. So conductor resistance increases with increase in temperature. That you will learn in the current electricity. Resistance of the conductor increases with increase in temperature. Okay. So the resistance of the conductor we can also take as a thermometric property to construct thermometers. Understood or not? So different properties are there that changes with temperature. Those properties we can use as a thermometric property. So what is a thermometric property? The property that changes with temperature. And thermometric property we can use to construct thermometer. Understood? That is, they are not going to ask what is a thermometric property, write the definition on that. Okay, but we should know what is a thermometric property, so it changes with temperature. Okay. So older thermometer, earlier when we were making the thermometer, we were using the two reference temperature that will be constant at a constant pressure. Okay, like we know that water get freeze at 0 degrees C when the atmospheric pressure is 1 atm. So when the surrounding pressure is the 1 atm, water will always get freeze at 0 degrees C and it will boil at 100 degrees C. This temperature is fixed. Means at 1 atmospheric pressure, pressure will change, so this data will change. So at 1 atmospheric pressure, water will boil at 100 degrees C and it will get freeze at 0 degrees C. So these two temperature we take as a reference temperature of the older thermometers. Okay. So that reference temperature So that reference temperature we say this is the one is the lower temperature is the LFP, and higher temperature we say that it is a UFP. What is the LFP means? LFP is the lower fixed point, and UFP is called the upper fixed point. So lower fixed point we take as a ice point, and upper fixed point we take as a steam point or boiling point. Okay, so to construct thermometer we take the two reference temperature. One is the lower fixed point and one is the upper fixed point. Lower fixed point that we say the ice point, and the upper fixed point we say the steam point. Okay, so in the different scale, LFP and UFP will be different. Okay, now we will learn the different lower fixed point and upper fixed point for the different scale. So most of that you know. So suppose I am saying this is the scale LFP, UFP, and number of division. So in Celsius scale, what is the lower fixed point we take? Ice point is the 0 degree C. So lower fixed point we take as a 0 degree C, and upper fixed point we take as a 100 degree C boiling point, and total temperature difference is what? 100. So this 100 is divided into the 100 equal division. So number of division will be 100, and we can say one division is equal to 1 degree C. Okay. Similarly, Kelvin scale lower fixed point is the what? 273.15 Kelvin. Upper fixed point is what? 373.15 Kelvin. Okay. And again temperature difference is 100, so that is divided into 100 equal division, and here one division is equal to 1 Kelvin. Okay. But in the numerical problem we use the 273 only, but actually it is a 273.15. Okay. Then Fahrenheit scale, lower fixed point is the what? 32 degree F. Means if I put Fahrenheit scale or Fahrenheit thermometer in a ice, then what it will show? It will show 32 degree F. Okay. And I put the Fahrenheit scale in a boiling water, so it will show 212. What is the difference of the temperature? 212 minus 32, that is a 180. So total number of division it will have 180. And one division what you will have? 1 degree F. Okay. So these three only we have to learn. Rumor Rankling, that is not required. Okay. Now suppose I am asking by using the common sense, you will say the answer. 1 degree F will be more or 1 degree C will be more? C. Why? Because the same temperature difference is divided into the 100 division in a Celsius and Kelvin, and that divided into the 180 division in a Fahrenheit. So Fahrenheit, each division will be small. Each division is small, so that's why Fahrenheit 1 degree F will be lesser than 1 degree C. Okay. Got it? Now for different thermometers, suppose I am taking the Fahrenheit thermometer and Celsius thermometer, and I am measuring the body temperature. So what is the Celsius thermometer will show? What is the Fahrenheit thermometer will show? Suppose I am measuring the body temperature by the Celsius scale, Celsius thermometer, and the Fahrenheit thermometer. What they will show? Fahrenheit will show how much? I mean, you should know what is the body temperature in the Fahrenheit. Okay, 98.7 and 37 in the Celsius. and 98.6 or 98.7 in the Fahrenheit. Okay, so it means they are measuring the same temperature, body temperature, but their readings are different. Okay, so how we can convert the one scale into the other scale? So for that we use the one quantity that is called the thermometer scale identity. Thermometer scale identity, and that TSI will be equal for all scales. At a given temperature, TSI will be equal for all scale. At a given temperature, TSI will be equal for all scale. Okay, so at given TSI, that TSI, how we define that is a X minus LFP upon UFP minus LFP, that is equal to constant, or equal we can say for all scale. Means at a given temperature, if any temperature I am saying, so in that temperature I can say what TSI, that is a thermometric scale identity. That quantity will be constant or equal for all scale. Like I'm using the Celsius. Okay, I want to convert the Celsius into the Fahrenheit at any temperature. So I will put the X value is what here? X value is the reading in a given thermometer. Reading in a given thermometer. Like Celsius scale is showing 37. So I will put the X value 37 minus LFP of Celsius scale upon UFP of Celsius scale minus LFP of Celsius scale. I want to get the relation between Celsius and Fahrenheit. So suppose I need how much degree Fahrenheit will be in the 37 degree C. So X value Celsius 37, LFP of Celsius and UFP of Celsius, that is equal to temperature in a Fahrenheit scale minus LFP of Fahrenheit scale upon UFP of Fahrenheit scale minus LFP of Fahrenheit scale. So means this quantity will be constant or equal for at any given temperature for all the scale, where X value you will put the temperature in that scale. X value is the temperature in a given scale. Like you are taking the Celsius, so X value will take the Celsius, and LFP, UFP you will take Celsius. Then you will put the other you are equating, so X value you will take the like Fahrenheit, you will put the X value in the Fahrenheit, LFP of Fahrenheit, UFP of Fahrenheit minus LFP of Fahrenheit. Got it or not? Okay. Okay then. So X we can say temperature in a temperature in given scale. Okay, so we'll put the temperature in a given scale. Now on the basis of this TSI, we can say what? Like we want to get the relation between Celsius, Fahrenheit and Kelvin. Okay, so suppose I want to get Celsius and Kelvin. So X value I will put in Celsius. So C minus LFP of C is what? 0 upon UFP of C is what? 100 minus 0. That will be equal to what? At the given temperature, Celsius reading is C. Kelvin reading is suppose K. So K minus LFP means 273.15 upon 373.15 minus 273.15. That is equal to Fahrenheit. Suppose that degree in the Fahrenheit scale is showing F. So F minus 32 upon 212 minus 32. So from this directly you can say C upon 100, that is equal to K minus 273.15 by 100, that is equal to F minus 32 by 180. Okay. Got it? So this relations we will use to convert like C to the K, K to the F, F to the C. From this we can get, suppose they are asking they have given the temperature in one scale and they are asking what is the corresponding temperature in the other scale. This relation we can use. Like here C and K relation. So we will equate these two. From this 100 and 100 will cancel out. So K what we can say? C plus 273.15. What I said, I am writing 273.15, but in the numerical problem we take the 273 because 0.15 we can ignore. Okay. Fahrenheit and Celsius relation, then this and this you will equate. From this what you will get, F is equal to 9 C by 5 plus 32. So if you can mug up, so it is better you can mug up this relation. Otherwise, if you forget, you can equate these two, you will get this relation. F is equal to 9C by 5 plus 32. Okay. Got it? Now suppose I am asking, convert or find value of minus 120 degrees C in degree F. Means if you have the Celsius temperature is the minus 120, what is the corresponding value in the Fahrenheit scale? Tell fast, what is the answer? Tell fast. Minus 120 degrees C you have to convert into the degree Fahrenheit. Then we will use the F and C relation. So degree F I want. So degree F, that F you will say what? 9 by 5. C, what I have given, minus 120 plus 32. Okay. 53.6 minus 216. So 5 and this 120, what you will get? 24. So minus 24 into 9. So 24 into 9 you will get 24 9s are 216. Minus 216 plus 32. So minus 216 plus 32. So minus 184 degree F. That is the answer. So minus 184 degree F. Vikram, how you got 53.6? Okay. Sign changed. So these are the mistakes we do in an exam also, and then we call it is a silly mistake. But due to that, we lost the 5 marks. Okay, so these types of mistake we have to avoid, and that perfection will not directly come in the exam. That will come in the practice also. We have to avoid the mistake. Okay. Everybody got minus 184 degree F? Okay. Now, sometimes like suppose here I am asking to convert the one scale into the other scale. Okay. Sometimes what will happen, they will ask the temperature difference. Temperature difference, like formula of the heat Q is equal to ms delta theta. That delta theta we use as a temperature difference. That is a temperature difference. So if suppose I am saying 1 degree C temperature difference is equal to how much Kelvin? 1 degree C temperature difference will be how much in Kelvin? So temperature 273, 9 by 5. Okay, listen now. What I said, to convert one scale to the other scale, we will use this TSI. If they are asking about the temperature difference, we have to convert the 1 degree C temperature difference into the other unit. Okay. So temperature difference means delta theta. So we will take what here? This is the scale. Okay. I need the delta theta. So delta C, delta K, delta F. So you can differentiate in all the sides. You can differentiate, then you will get the delta. Means DC or delta, we can take it like same. Okay. So if I differentiate, so what I will get? Delta C by 100. Like x by 100, what is the differentiation? Dx by 100. So that is I am writing delta C by 100 is equal to K minus 273. 273 differentiation is 0, delta is 0. So delta K by 100. So delta C by 100 is equal to delta K by 100. That is equal to F minus 32 by 180. So F, we can take that delta. So delta F, delta of the 32 is the 0 upon 180. Okay. Or other form you can write, more simplify you want. Then you can cancel by the 20. So delta C by 5 is equal to delta K by 5 is equal to delta F by 9. So this is the relation between delta. So when you have to convert the one temperature into the other temperature, that is a temperature difference, not the temperature scale like Celsius and Kelvin. It is a temperature difference. So temperature difference you want to convert into the from one unit to the other unit. So we will use this relation. From this we can say delta C and delta K, they will be equal. Why? Delta C by 5, delta K by 5. They are equal. 5 and 5 cancel out. Delta C is equal to delta K. Yes or no? Means temperature difference in the Celsius or temperature difference in the Kelvin, they will be same. Got it or not? And delta F if you want to find, so delta F is equal to what? 9 by 5 delta C. Delta F is equal to 9 by 5 delta C. Okay. Got it? So when you like where we can use this. So suppose everybody know the heat formula, Q is equal to ms delta theta. So S we can say what? Q by m delta theta. Suppose unit of the S I am writing joule per kg degree C. Okay, joule per kg degree C. Suppose this is the unit of S I am writing. They are asking what is the unit in the Kelvin. What is the unit in the Kelvin? So this I can say what? Joule will be joule kg degree C. Here this degree C represent the delta theta. This degree C came from the delta theta. Now delta theta in a degree C and Kelvin they are same. So degree C you can replace by Kelvin. Understood? No. How we can write this? Okay, C by 5. No, how we can write? C by 5 is equal to K by 5 is equal to F minus 32 by 9. Gagandeep. We are not right, na? Delta C by 5 is equal to delta K by 5. That is right. But how you can write F minus 32 by 9? You cannot write, na? Then you will get delta F by 9. Okay, Gagandeep. Okay then. Okay, so difference of the temperature we can use this, and the conversion of one scale to the other scale we can use this. One simple problem I will discuss. Like suppose I am asking fast, you will say. Suppose you have to convert 1 degree C, 1 degree temperature increase in 1 degree C, you have to write in the Kelvin and the Fahrenheit. Tell fast what is the answer. 1 degree C increase in temperature, delta theta means change in temperature is 1 degree C. What will be the value in Kelvin and Fahrenheit? Tell fast. 1 degree C increase in temperature, 1 Kelvin and 9 by 5 F. Very good. 9 by 5 in F and 1 Kelvin. Delta theta and delta theta will be same in Kelvin and Celsius. So in a Kelvin answer will be the 1. And Fahrenheit you can write here delta F is equal to what? 9 by 5 delta C. What is the delta C? 1. So what is the delta F you will get? 9 by 5 or 1.8 degree F. So 1 degree C temperature difference we can write as a 1 Kelvin or 9 by 5 degree F or 1.8 degree F. Understood? Okay. Got it? Tell fast. Okay. So this is over now. Now suppose one question. I'm saying suppose you have the boiling water. Okay. And you have put the two thermometers. One is the Celsius and one is the Fahrenheit thermometer. So when we have the boiling water, in that we have put the Celsius and the Fahrenheit thermometer. What the Celsius scale will show? Tell fast. What is the Celsius scale will show? 100. And Fahrenheit will show 212. Why? Because its steam point 373, Vikram. 212. Because the steam point of the Fahrenheit scale is the 212. So Fahrenheit will show 212, Celsius will show 100. Okay. Okay. Now I am cooling the water. After some time, Fahrenheit scale is showing 140. When we started cooling the water, Fahrenheit scale now after some time, Fahrenheit scale is showing 140. What is the Celsius scale will show then at that time? If what is the answer? 60. Are 36 nearly? How? Calculation mistake all the time. Then Fahrenheit scale is the 140. So 140 I have to convert into the 140 degree F I have to convert into the degree C. Then we will use the F and C relation. What is the F and C relation? C by 100, that is equal to, or directly I am using now, I am not writing this. F is equal to 9C by 5 plus 32. So F is what? 140. Then 32 will shift this side. Then 5 by 9 you will multiply. Then you will get the degree C. Okay. Then for 140 minus 32, what you got? 108. 108, 9, and 108 you will get 12. So see what you will get? 60 degree C. Everybody got? Okay. So we got the temperature what? When the Fahrenheit scale is showing 140, so Celsius scale will show 60. Suppose I say, I'm not asking directly this, what the Celsius scale showing. I am saying how much temperature fall in the Celsius scale. How much temperature fall in a Celsius scale? 40. Why? Earlier it was boiling, so that was 100. Now it is showing 60. So how much temperature fall? 40. Getting or not? So temperature fall is the 40. But if suppose directly I am asking the temperature fall, so there is another way we can calculate. If I am asking, the both thermometer were initially in the boiling water. Now Fahrenheit scale shows 140. How much temperature fall in a Celsius scale? How much temperature fall in a Celsius scale? I am directly asking fall. Okay, so there is a maybe I cannot use this. I can directly use the delta relation. So if I am asking how much temperature fall in a Celsius scale, then I will use what? We know delta C by 5 is equal to delta F by 9. Okay. Then delta C we can say what? Delta C by 5, or delta C directly I am writing. Delta C is equal to 5. What is the delta F? Earlier 212, now 140. So what is the difference? 72. So delta F I can say what? 212 minus 140 upon 9. So this is a 72. 72 and 9. 9 8s are 72. So what you will get? 5 into 8. That is equal to 40 degree C. So in a Celsius scale, how much temperature fall? Directly you got delta C is equal to 40 degree C. Understood? So for the temperature difference, we can use the difference relation to conversion from one scale to the other scale. We can use the, okay. Sir, here you use that only now, sir. So both we can use. Like you can get the exact temperature 60. After that 100 initial, 60 showing. Now how much fall? 40. That is the one way. Otherwise, directly if they are asking the fall, we can go through this formula also. Why again you are writing C by 5 is equal to F minus 32 by 9? Okay, conversion factor we can use. Here we can directly use, we can use to get the value in a Celsius, we can use C by F is equal to F minus 32 by 9. Then you will get the value in a C, but you will get the answer 60. If I am asking fall, then you will say 100 minus 60, that will be equal to 40. Gagandeep. Got it? So first we can find the C temperature. After finding the C temperature, then from the original you will subtract, you will get the difference. Okay. Completed. Okay. Now one more problem, but I have to go to the other. So okay, fast I will discuss. Then after that you will do. If you will not understand, in the next class you will ask. Okay, suppose we have the 3 scale A, B, C. Okay. Here LFP and UFP of the scale they have given. So ice point of this scale is minus 20 degree A, and steam point is the 70 degree A. B scale 30 degree B, and the upper fixed point is the 120 degree B. Okay. C scale 0 degree C, and the upper fixed point is the 90 degree C. Suppose we have the three any hypothetical scale A, B, C. In a scale A, lower fixed point is the minus 20, upper fixed point is the 70. Similarly, B 30 and upper fixed point 120, and C scale 0 and 90. You can, one thing is common in all the three scale, the difference of the temperature or the number of division is the 90 in all. Yes or no? 70 minus of minus 20, 90. 120 minus 30, 90. 90 minus 0, 90. Okay. Okay. Now these are the three scale we have given. If reading of A, B and C are 50 degree A, 50 degree B and 50 degree C. Okay. So which thermometer is at the high temperature? What is the order of the temperature of the thermometer? If all the three thermometer is showing 50, reading 50, means A is showing 50 degree A, B is showing 50 degree B, and C is showing 50 degree C. So which is at the higher temperature, or what is the order of temperature? Vikram, A, C, B. So one thing, next class I will say by using the mathematics, because maybe by using the common sense we are unable to get in that type of exam or not. But we can get by using the common sense as well as mathematics also. So calculation we will do in the next class. Here I am asking, all are showing the 50, 50, 50. Okay. So means their ice point and the steam point are different. So means they will not at the same temperature. Okay. That is right. So here 50 degree A means it is a closer to the 70. So 50 degree A is the closer to the 70. It means 50 degree A is the closer to the steam point. In a A scale, if I am getting the reading 50, so it means it is closer to the steam point. Okay. Then in a B, 50 means it is a closer to the ice point. That is a 50 degree B, because 30 here 120. So in a B, you will be close to the ice point. In a C, 45 is mid, because 0 and 90, so middle will be the 45, slightly above the middle. So then it is a 50 degree C. Now you will say, which is closer to the steam point? A. Which is closer to the ice point? B. And which is the just middle, above the middle? C. Which is at higher temperature? Tell fast. A. A is at higher temperature, then A is at higher temperature, then C, then B. Okay. So what is the order of temperature? Temperature of A is greater than temperature of B, and then temperature of C, then temperature of B. So highest temperature of that A scale is measuring, then this method is easy, yeah, but maybe it will click in the exam at that time, we don't know. Okay, so maybe we have to know the mathematics also. So next class I will discuss about that process, mathematical process. Okay. Okay, bye bye. Okay.